How long will it take for $2,500 to double at 10% interest compounded quarterly? So because it tells us that the interest is compounded quarterly, we know that we need to use our compound interest formula. A is equal to P times the quantity 1 plus R divided by N raised to the N times T power, where N is the number of times a year that the interest is compounded. So N is equal to 4 in this case. Now we are starting with an initial investment of $2,500. So that's going to be our P value. P is equal to 2,500. And we're solving for how long it takes for the investment to grow, to double in this case. So we're going to be solving for time. Now remember A is the accumulated value. It's the after amount. So if we want our investment to double, and we start with $2,500, then we're ultimately looking for our A value to be 5,000. So our resulting equation is going to be 5,000 is equal to 2,500 times the quantity 1 plus. Now remember the interest rate, the 10%, needs to be written as a decimal. So that would be 0.1 or 0.10 divided by N, quarterly, that was 4, raised to the N times T power. So that will be 4 times T. So this is our resulting equation. And this equation is an exponential equation. So remember, our first step in solving exponential equations is to isolate the exponential quantity. So therefore, in this case, I need to divide both sides of my equation by the 2,500. So now I'll have 2 is equal to the quantity 1 plus 0.10 divided by 4 raised to the 4t power. Now I would go ahead on your calculator and take a look at this quantity 1 plus 0.1 divided by 4. And you'll notice this is equal to 1.025. And this is an exact decimal. It doesn't go on forever. It stops after the 5. So because this is an exact decimal, I think I'll go ahead and use the exact decimal form. Now notice, you would not want to round here. For example, you would not want to call this 1.03, because if you round in the middle of the problem, then you're going to be losing accuracy, because we'll probably be rounding at the very end of the problem as well. So we want to leave those decimals as exact as we can. If it's not an exact decimal, then you would probably want to use the storing feature on your calculator. So what we have here is an exponential equation. So we have two options to solve exponential equations. You can either rewrite this equation in log form, or you could take the log of both sides of the equation. And I prefer to write it in log form. Remember that you're always going to start with your base. So the base of this exponential equation is 1.025. So when I write this in log form, I will have log base 1.025 of 2 is equal to the exponent, which is 4t. And then solving for time, I just divide both sides by 4. So I have time, t is equal to log base 1.025 of 2, all divided by 4. And if you're on a TI-84 calculator, you have a shortcut for your logarithms that are unknown bases, or excuse me, not unknown, but bases other than 10 and e. So you can use your shortcut menu on your calculator. However, if you are on a TI-83, or perhaps you have not updated your calculator, then you would need to use your change of base property or change of base rule and change this into a base 10 or a base of e. So just a reminder, your change of base property, when you have logarithm, a log base b of some value, we'll call it m, you can change it into base 10 by taking the log of m divided by the log of the base. So those are both base 10 logarithms. You could also change it into a base e logarithm, a natural log, which would be the natural log of m divided by the natural log of b. You can change it into any base of your choosing, but of course base 10 and base e are popular because our calculator does those easily. So on the TI-83, you would need to enter this as the log of 2 divided by the log of 1.025. And then you would divide this quantity by 4. So please be sure that you're definitely using your calculators and pausing the video as necessary to make sure that you're getting the correct decimals on your calculator. And for this one, it looks like we get return a value of approximately 7.02. And since we were solving for time, which is measured in years, this would be 7.02 years. It takes about 7.02 years for my $2,500 investment to double.